So chapter 5. Chapter 5 is the last big chapter. We might do one section from chapter 6, but basically we're on the home stretch here, people. All right. So log properties. In calculus, we use the natural log all the time, okay? Because it makes things easier, as you will find out today. So if you log, whether it's base 10 or any base, the number 1, the answer is always 0. It is. It's 0. If you have the arguments, which are the numbers you're logging, in this case a, b, and you're multiplying those arguments, what can you do with them? You can break them up into the natural log of a plus the natural log of b. So you can separate them. We will use that in this unit. Also, number 4, if you're dividing the arguments, then you are subtracting them. All right. We will use that. And then number 3, what do you do with an exponent if you are logging a number? It can fall down in front. And you get n natural log of a. We will use that a lot in this chapter. Okay? These are the 4 main ones. Well, the natural log of 1, yeah, we'll use it when we're doing definite integrals, but the other 3 we'll use almost every single time. All right. So we'll just do a couple practice ones. I'll give you a few questions, then we'll move on to the calculus. So natural log of root 3x plus 2. How can I break this up? Rewrite it. Yeah. So we don't want square roots. Like, we don't like square roots in calculus, right? So we're going to write it as 3x plus 2 to the 1/2. Then what can I do with the 1/2? You can drop it down. And you will see that will make our life a lot easier. And then you're for what we're doing right now, because we're not doing any calculus or anything, you would just stop there. We'll do one more example. Break that up, please. And we'll see if we get to the same spot. Did I move it up too far? Isabel? Did you want to see the top ones? You're welcome. All right, there's the expanded form. 2 natural log x squared plus 3 minus 3 natural log x minus 1/2 natural log x plus 1. Yes? Huh? What? Where did the minus 3 come from? From the exponent on the x cubed.
Where did x cubed come from? Isn't it supposed to be -3? Because it's going on. Oh, did you just put the x cubed from the x plus 1? Okay, just sit. Oh, never mind. Oh, that makes sense.
No.
Okay, I see.
So the first line, I just break them up. So this is up top. So it's there. These are being divided. That means they're being subtracted. And then I just drop the exponents. Boom.
Wait, could we just put them together, the 3ln minus half, or do we have to?
No. Just,
Like the x cubed times x plus 1.
I would break them up. You'll see that has an advantage when we start doing the calculus. Okay? All right. Is there any questions about that for people that took logs? Okay. So I'm just going to give you a couple questions and then we're going to move on. Page 325, numbers 19 to 20. 19 to 29. Which looks like a lot, but you're only doing the odd, so it's actually 5 questions. And then we will start the calculus. Okay, so just 5 questions. Quick little review. Okay, so the natural log function. We got to talk about that first. The natural log function is defined as an integral. Right? Nobody ever tells you that until you calculus because you don't know what integrals are. But the natural log function is the area under the curve 1 over t from 1 to x, i.e. this area here. So when you say, when somebody writes, what is the natural log of 2, what you're actually calculating is the area under that curve from 1 to 2. That's what you're doing.
Yeah, how do you write that out?
Yeah, because what's at 0? Vertical asymptote, because it's 1 over t. Right? So, all right, so you're actually calculating the area. Now, what we learned in the previous chapter, if I say, what's the derivative of this function? What's the easy way of finding the derivative of an integral function? You just plug this into there and multiply by the derivative of whatever this is, which is 1. So what's the derivative of the natural log of x? E. Somebody said it.
0.
I said E, I don't know.
It's not e.
1. Undefined. Infinity.
So this is what the function is. Okay?
1 over x. Yeah.
It's 1 over x.
So Talia, you're close.
I didn't know it's 1 over x.
And
Oh!
The second fundamental theorem says if you take the derivative of an integral, they essentially cancel each other out, right? So you just plug in the variable, and then you multiply by the derivative of that variable, but in this case, that would be 1. So it's just 1 over x. So if I had the derivative with respect to x of the natural log of u, it would be
1 over u.
times u prime, or du dx if you want to. You could write it like this: 1 over u du dx, because you have to use chain rule. If you know those 2 rules, you can do all the questions for the natural log. Okay? So we're going to practice this now. It's actually fairly straightforward. No, it's not. All right. The derivative of the natural log of 2x. Sorry? 3?
1 over 2 times 2. Huh?
It's 1 over whatever's in there times the derivative of whatever that was, which is the u primed. What's the derivative of 2x? 2. So what happens to the 2's? They cancel, and you get 1 over x.
I haven't even read down the question.
Okay.
This guy's about 2,000.
Oh, so is it just second fundamental?
Well, it was to get the original, but now we can just use the formula.
Yeah.
Okay, no.
Okay. So the derivative of the natural log of x squared. So you take whatever's inside the natural log and you just put it in the denominator. right? That is this bit, 1 over u. Okay, so I just go, all right, it's 1 over x squared plus 1. But I have to remember to use the chain rule. So I multiply by the derivative of x squared plus 1, which is?
2x.
And you're done. I would just write it as this, 2x over x squared plus 1. What is going on here? And you're done. That's it.
Can we split it
apart? You can't split it apart because there's no natural log.
Like 2x over x squared.
That's not the same thing. That's only if you have a single denominator, then you can do that. But if you have two terms in the denominator, you can't do it. Okay. The derivative of the natural log of x to the power of 2. Hmm? 2x over x squared. That is correct. But you can also use your log rules to simplify it before you do it. So, if you drop the 2 down, you can rewrite it like this. Right? Watch. What is, so 2 is a constant, right? So I don't really care about that. So I just put that down. What's the derivative of the natural log of x? You're done. And you're going to see when we have bigger, more complex things, using that idea will make your life super simple. Not super simple, but easier. Okay? All right. What if you have this? I don't know why I put square brackets, but natural log of x all cubed.
What's the validity of the natural
The
log?
concentration of natural.
It's the concentration. Yes, I don't like the square brackets. Let's do round brackets. There we go. The molarity of the natural log. All right. So what rule do we have to use? Oh my gosh. What rule do we have to use? Chain rule. So the 3, you start on the outside. The 3 falls down times the inside, take away 1, so it's all squared, multiplied by the derivative of the inside, which is 1 over x. That's it.
You run that back?
So because the natural log is being cubed, you have to use chain rule. So you start with the outside function, which is the 3, power of 3. You drop down that 3, take 1 away from it. So that's why I have 3 natural log of x squared, multiplied by the inside derivative, which is 1 over x. Yeah? Okay. Okay. So let's do something a little more interesting. There you go. Again, I'm using these square, but I don't know why I'm using square brackets. Maybe it's all the chemistry talk. Yeah, so it's like that. The natural log of that junk. I want to do the derivative. Okay. That's gross, right?
Wait, is the x inside?
Yeah, everything's inside the natural log. All right. That's yuckies. So, use your log rules to expand it. So what you can do is rewrite it as natural log of x plus 2 natural log x squared plus 1 minus the natural log of 2x cubed minus 1. No. That is just breaking it apart using the log rules. What you just did. Yeah. Okay. So does that make sense so far?
Yeah.
All right. Then you can do each one separately. What's the derivative of the natural log of x? What's the derivative of 2 natural log x squared plus 1? Do I care about the 2?
No.
So it's a constant. What's the derivative of the natural log of x squared plus 1?
Yeah.
Times
Times 2. Oh, wait.
2x.
Oh, the inside version.
Yeah. Minus, what's the derivative of the last one? There you go. That's the derivative.
You just want to do it to us. Same for that.
Okay. Yeah. I mean, I can multiply this 2 and get 4x, but whatever. That is your derivative. Okay. So it takes something that is gross. If you were going to do this the other way, it'd be 1 over that, this gong show, times the derivative of this gong show. But the derivative of this gong show is going to involve product rule, chain rule, quotient rule. And we did those in chapter 2. Remember those questions that were massive? But if it has a log, you can separate it like this, and then just do each one separately, and you're done.
It's logs are friends, man.
Logs are your friends. See? All right. Let's do a couple other ones. We're almost done. Okay. I don't know what number this is.
6.
6? Okay, number 6. So, what if you have this? Okay.
Oh, okay. What they used to do.
So our function is y is equal to x minus 2 all squared over x cubed times the root of x squared plus 1. We did stuff like this in chapter 2. All right, these were the big long ones, and then you had to factor out something and simplify it. Like it took like half a page. All right, I still want to know the derivative. Are there any logs in there? No. But you can put logs in there as long as you do it to both sides. Okay, so you can do it the old school way. I'm telling you right now, it's going to be messy. Logs will make it easier. So you're going to log both sides. So you're going to go, okay, the natural log of y is equal to the natural log of all this. And I'm going to write the square root as x squared plus 1 to the power of a half. Okay? All I did was put a log in front of both sides. What you do to one side, you have to do the other side. Right? That's grade 3, 4, I don't know, whenever you learn that. All right? Now, what are we going to do? We're going to break this part up. So we're going to go and drop the exponents, please. A lot of my other grade 12s don't drop the exponents. And it makes it more complicated than it needs to be. Bring the exponents down. Does everybody understand what I did? Okay. We all good here? All right. Now we can do the derivative. Once you don't leave these exponents up, I'm going to say it again because people do that and then it's still complicated. always bring the exponents down. Now we can do the derivative. So we'll do the right side first, then we'll do the left side. Okay? So what's the derivative of 2 natural log x over 2? X minus 2.
2 over x.
There you go. 2 over x minus 2, right? Because it's 1 over that times the derivative of x minus 2, which is 1. But the 2 is still sitting there. Minus 3 over x. Do we agree with that? Okay. Minus the 1/2 is still there. The x squared plus 2 is still there. What goes up top? 2x. So I can cancel those 2's, right? Just cancel them like that. Okay. That's the derivative of the right side. We have to do the derivative of the left side. Okay. What's the derivative of the natural log of y? 1 over y times y primed. So you can write it as y primed over y. No. Because what are we trying to solve for? The derivative, or y primed, right? dy dx is y primed, right? Remember that? So I have to multiply y up to the other side. Okay, so y primed is equal to y times all this stuff. No, don't do that. Still not done. It's one other step. What's y? That's y. Right? So that sits in front of everything. So you multiply that up, so you get, or so you change out the y and you go, it's x minus 2 squared over x cubed root x squared plus 1 times
Oh, I see.
because y is the initial, right? Yeah. That's the derivative, which is gross, but the actual process to get there is not actually that difficult when you use logs. Now, if you did it the other way, be my guest, but good luck, and it's going to take you a lot longer to get there. The logs will make it faster and more straightforward. Okay? All right, this is called, when you log both sides, it's called logarithmic differentiation. Do you want me to write that down? This is called logarithmic. Yeah. When you log each side, that is using logarithmic differentiation. Okay, I'm just going to give you questions to grind out for the rest of the class, and then we'll move on to other stuff tomorrow. What's that? That is the finale of today's lesson. Here are the questions, page 325, 41 to 59 odd, and 73, and 89, 91, and 93. I strongly recommend you do all of them because each lesson is going to build, because we're going to actually start doing integration. This chapter is both integration and derivatives mixed together of natural logs and e to the x's and bases other than e, exponential functions. So please practice. All right.